Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to focus our attention on our groundwater zones and soil. Well, the water that falls in the form of precipitation, it's going to hit the surface, and then where does it go? Essentially, what you're going to need to know is that the water is going to interact with the surface in a couple of different ways. It can either evaporate back out into the atmosphere, it can either travel as runoff if the soil is completely saturated, or it's going to allow it to, or the soil is going to allow it to infiltrate into the ground, okay, which means it's going to allow it to sink into the ground and become what's called groundwater. And that's what we're going to focus on here. Water is going to fall onto the surface, it's going to sink into the ground, and it's going to travel down through the soil as far down as it can possibly go. Eventually, it's going to hit a layer of rock called an impermeable layer, which means it will not allow water to pass through any further. At that point, the water is going to start to accumulate into a zone called the zone of saturation. This zone means that all pore spaces in between your soil particles are completely filled up with moisture. Now, that's an important layer for us because that's where a lot of our fresh water is going to come from. Above that's what we call the zone of aeration. Now, mind you, some of the water that's going to infiltrate into the ground has to pass through the zone of aeration, but it's going to sink down and build up in the zone of saturation. So the zone of aeration does have a little bit of moisture in it, and that makes sense because that's the zone where a lot of our root systems are going to be found. But the zone of aeration is primarily made up of air pockets. So the little pore spaces are predominantly going to be filled up with air. So zone of aeration is filled up with air, zone of saturation is filled up with water. The boundary between the two is what we call the water table. Now, water table is going to be identified by the dotted line. That's going to basically separate the zone of aeration and the zone of saturation. Now, mind you, the two zones are going to change shape based upon the amount of precipitation that you get. And the great thing about lakes and streams, that's actually the water table at the surface. And that'll give you an idea about how high the water table is going to be underneath the ground. So if the lakes and streams are really high, it means you have a really high water table. If your lakes and streams are really low, it means you have a very low water table. So, when you talk about your different groundwater zones, what's going to be important here is to understand that they do change size based upon the amount of precipitation. So sometimes you can get flood stages, which means that you have a very high water table, which means you have a very large zone of saturation, or you can get droughts, which means you have a very low water table, very small zone of saturation. So there's your drought condition, and there's your flood condition. Now, your water that infiltrates into the ground has to pass through different layers of soil. Now, different layers of soil are what we call horizons. Now, soil is made up of really two major objects here on the planet. It's made up of biological material, whether it's dead and decaying plant material or dead and decaying animal material, whatever it may be. A lot of these horizons are going to be made up of organic material. And the soil itself, a lot of it's going to be made up of really, really finely broken up rock fragments or weathered rock fragments. So let's just talk about some of the distinct layers that you're going to need to know. Probably the most important layer is going to be the O horizon. This is a very dark layer. It's a much more of an organic layer. It's many times called topsoil because it's so dark in nature. A lot of times you can get bags of this in Home Depot, and very, very dark in nature, which indicates it has a very high organic material. Sometimes it's called humus. Underneath that's going to be the A horizon. This is a very mineral-rich horizon, and it's called a subsoil. Below that is going to be the B horizon, and we call that the residual soil layer. That word residual just means that it matches up with the layer below it. So the layer below the B horizon is going to be the C horizon. This is your impermeable rock. So the B horizon is actually made up of the same material and the same composition as the impermeable bedrock. So out of those four horizons, the O horizon is by far the single most important layer that you're going to need to know because of its organic content, the fact it's made up of weathered rock remains, it's also very dark in nature, and it's also called humus. Okay? With that being said, this is an actual photograph of some of the different layers. It looks like you have definitely three distinct layers in that particular picture, and you'd be able to identify the different horizons. And here's just an artist rendition of some of them as well. In this case, they go O, A, B, C, and then they also include R in there as well. So depending on the detail of the diagram, will give you an indication about how many horizons you need to know. But for Regents purposes, the O horizon is by far the single most important. So with that being said, thanks so much for joining me, and we'll see you soon.